Hello everyone, today we are going to discuss another topic in the surveying series of our videos. This topic is very important when you are preparing for different type of examination like your semester examination, your B.Tech or diploma examination, your SSC JE examination is a very sought after topic, and today we are going to discuss the basics of this topic, and the topic's name is labeling. So let us first define the topics, that the definition of labeling. A labeling is the process of determining the elevation of different points on the earth's surface, or in other words, finding how high or low a point is as compared to another point or a reference level. So in very basic understanding terms, we can say that height of a certain point on every point on earth's surface or below the earth's surface has a certain height. The height of this object or height of this point can only be figured out with the help of a reference point. That means, for example, this point or this height of this rod is like 2 meters above the ground. Okay, but this is also just 0.6 meter if my hand is used as a reference axis, right? So the height of any object or height of any point on, above or below the earth's surface can only be figured out when we figure out what our reference axis is. That means that we can tell the height of any point on earth's surface only with the help of a reference axis, right? So the labeling process helps us in understanding that what is the actual height of a point with respect to any assumed axis. That assumed axis is called your datum. So a datum is a reference surface or level to which the elevation of point are referred. That means that you can figure out that this is your reference axis, and this reference axis will act as a datum plane for calculating the height of any point on, above or below the earth's surface. There can be two types of datum. The first type of datum is mean sea level, and the second type of datum is assumed datum. So in big construction project or in most of the construction project, we always discuss the height of different points on earth's surface with respect to mean sea level. That means the average sea level is considered as a point of reference for calculating the height of different points on the earth. Now this mean sea level gives us the uniformity that we required in a construction project, right? So mean sea level is uniformly accepted throughout the world just because it gives us a uniformity during the construction, which is very important for a construction project. Now also in a smaller project or at your college level, we can also assume the datum which might not be accurate. That is why this is called an assumed datum. Assumed datum, for example, that you have a college stairs or you have a certain concrete ground, that you assume that it is your datum, and you assume that the RL of this datum or the height of this datum is like 100 meter. Now you calculate the height of every other points in the surrounding with the help of this assumed reference axis or this assumed datum. That is why this is only accurate, or this is only used when the construction project is very small or you are practicing in your college life, right? So in college you do not have the actual benchmarks, you do not have the actual RL, so you can assume a particular datum and then you can carry on your work for your practice purposes. Or in a smaller construction project, the work can also be done with the help of assumed datum. That brings us to another important term, which is your reduced level. Then why is it called reduced level? The elevation of point is called reduced level. Why is it called reduced level? The reduced level of a point is the vertical height of that point above or below a chosen datum. So we have a chosen datum whose height is already known to us. For example, I consider that this ground is a chosen datum, and since this ground is a chosen datum, its height must be known to me, right? So when the height of this ground is known to me, I can calculate with the help of leveling instrument and with the help of readings that I have taken through a leveling instrument the height of different points in the near vicinity of this area. That is why, since the readings are taken and this reference axis is used for calculating the readings or calculating the height of every other points in this vicinity, that is why all the other readings are called your reduced level. That means you take observation with the help of a staff, with the help of a leveling instrument, and then with the help of the height that you had already figured out or was already known to us, with the help of that height you can calculate the height of all other points with the help of mathematical calculations, very simple mathematical calculation. That is why these readings are called your reduced level. Okay, then it brings us to another important topic and another terms. It is very simple. The term is benchmark. A benchmark, as I said, is a point of known RL. Any points whose RL is known to us is called a benchmark. These benchmark can be set up with the help of a GTS benchmark. That is, the Survey of India carries out a very precise survey to a very large extent, and then fix the positions of benchmark at various important places in the country. That means the benchmark is set up with the help of very precise calculation, with the help of very precise instrument, and it is conducted by the government through the Survey of India. This benchmark is obviously not available at construction projects or construction site. This is available at very precise location within the country, at very few positions within the country. Through this benchmark, that is the GTS benchmark, when we are undertaking a civil construction project, what we do is that we shift this GTS benchmark to a permanent benchmark. A permanent benchmark is any point whose location is likely to remain as it is, like a concrete floor which is not going to be broken, or we have inserted like a stone somewhere at our construction site which is likely to be as it is through a longer period. These benchmarks are called your permanent benchmark. But in projects we require benchmarks at different location. Why we require benchmark at different location? Because as we move further in your project, you cannot have the permanent benchmark everywhere. That means the ability of a leveling instrument is like 200 or 250 meters, up to which you can clearly read the observation of a staff. Then after that you have to have a newer benchmark. Also, what happens is that larger construction projects do not complete in a day. So you have to start your construction another day and yet another day. So since you are continuously using a benchmark and you have to continuously use a benchmark, you have to shift your permanent benchmark to various different locations, because you cannot start your day every time with a permanent benchmark. That is why throughout the construction site, at every 150-200 meters, there are temporary benchmarks which are to be used during the period of the construction project only. That means once the construction project finishes, these temporary benchmarks can be removed or these can be disturbed, and you won't have a problem. But this permanent benchmark has to remain fixed for any of the work, right? So the temporary benchmark is a type of benchmark which is shifted with the help of a permanent benchmark and a process called fly leveling, and we'll get to know more about different types of leveling in our next videos, right? Also, there is another type of benchmark which is arbitrary benchmark. As I discussed in the term arbitrary datum, assumed datum, when you are doing a project which is of very small extent, or you are doing a college observation, in those periods you can assume a benchmark which might not be accurate. In most cases it might not be accurate, and you will still have to work out your readings with the help of these benchmark only. So these arbitrary benchmark are not for large construction project, very small construction project and your college practice purposes only, right? Now this brings to us to another of very important words. These are backside, intermediate side and foresight. Students always get confused what a backside is, what an intermediate side is, and what a foresight is. A backside is clearly not something which is taken on the backside of the instrument. A backside can only be defined as a site which has been taken with the help of a leveling instrument when the staff was placed at the benchmark. So you have a benchmark, it can be permanent or temporary benchmark. You place your staff over the benchmark, that means at a point whose RL was already known to you, that is your benchmark. You place your staff at your benchmark, you take a reading on the benchmark, and this reading is called your backside. So in the start process of the leveling, the first reading is always going to be your benchmark. So once you have calculated the benchmark, you can calculate the height of instrument as the formula here. The height of instrument is RL of benchmark plus backside. So for example, if the RL of your benchmark was 100 meter and you took a reading on the benchmark, that is your backside, and the reading came out as 1.5, then 100 plus 1.5, 101.5 is your height of instrument. Then once your height of instrument has been calculated, you can calculate all the other elevations of different points with the help of staff readings while holding the staff at the position where your elevation has to be calculated. So you take your staff to a position, to a newer position, and you place your staff there, you take a reading. That reading can be your intersight or can be your foresight. Any reading which is taken from a certain instrument station can be an intermediate sight or can be a foresight. But how is it different? How are intermediate sight and how are foresight different from each other? That is the number of reading. For example, you have placed the instrument station here. With the help of your leveling instrument, you can easily read up to 200 meter. For example, with the help of a dumpy level, let's say, you can read 200 meter. But after this 200 meter has been completed, you won't be able to easily read the staff reading when you are, let's suppose, 220 meter. So what you do is that the last reading that you have taken, you will place your staff at that position only. You will keep that staff on that position only. That position is called your foresight position, and after which the instrument can be moved to a newer position in the direction of the survey. Okay, so you are holding your staff intact at that position where you took your foresight. That is the last reading which is from any instrument station is called your foresight, and you'll keep holding your staff at that position only because you can calculate the elevation of that particular point by height of instrument subtracting the staff reading, that is the foresight. Now since you have calculated the RL of this point, you understand that this point has become a benchmark for you, because as I said, benchmark is a point of known RL, and since you have calculated height of instrument minus foresight is the RL of this point can act as a benchmark. You move your instrument station and this is called your change point. So you have to, in the remark column of your table, you have to place change point here, and you change the instrument station, and at the very point where your staff was placed when you took the foresight, you will take another reading which would be called your backside. Okay, so now with the help of the RL of this point and the backside taken on this very point, you will have a newer value of height of instrument station, and when your height of instrument is found out, then you can get the RL of different type of point with the help of this new station. So that means in the process of leveling, we have to understand that the first reading is backside, all the other readings are intermediate side, and the last reading from an instrument station is the foresight. We'll keep holding the staff at that very position, we'll move the instrument to a newer position, and we will take another staff reading that would be called backside. We will add it and we'll have the new value of height of instrument. Height of instrument will change with the result of changing this instrument station, and height of instrument will have to be calculated at every instrument station. For example, you are doing 1000 meter work and you are changing your instrument position 5 times, so you will have 5 different values of height of instrument, and the staff readings corresponding to that height of instrument can be used to calculate the RL of the points in that vicinity only. Okay, so I hope this clears things for you. If you like this video, please leave a subscribe, leave a comment and share this among your friends. Thank you so much, and stay connected for more such videos.